Let's rescue a failing physics practical answer in under 60 seconds. If you're dropping marks on your Cambridge IGCSE Physics Paper 5 or 6, you are literally walking right into the traps examiners set on purpose. Today, we're doing a source-level breakdown of freefall, terminal velocity, and practical timing data to lock in those grade boundaries. Picture this: a student times a single pendulum swing with a standard stopwatch. Sounds fine, right? Wrong. This is the classic examiner chess trap, and falling for it immediately tanks your score. You might be thinking, hey, the period is just the time for one swing, so I'll just measure one swing. But the examiner is sitting there, red pen in hand, waiting for exactly that response. The absolute fatal flaw here is human reaction time. It takes your brain and fingers about 0.5 seconds to react when you click start and when you click stop. There's a biological delay. If a single pendulum swing only takes a second, a half-second lag completely destroys your measurement. You aren't measuring the pendulum anymore, you're just measuring your own lag. Look at this exact phrasing straight from our source material. Reaction times will influence the measurements. This is exactly why ordinary revision fails. Students just memorize equations, like speed equals distance over time, and entirely forget the physical limitations of the actual tools they're using. An equation is completely useless if the data you plug into it is already poisoned by human error. So, to guarantee those top marks and dodge these traps forever, we're going to apply a definitive 4-step framework to every single practical skills question. Step 1, spot the core concept. Step 2, figure out the evidence or data you need. Step 3, apply scientific reasoning to your apparatus. And step 4, write it down using precise examiner wording. Let's use this right now to fix that pendulum trap. Boom, here's your first quick win. We call it the multiple strategy. Instead of timing one swing, time 10 full oscillations, and then divide your total time by 10. By measuring a much larger chunk of time, that pesky half-second reaction error gets spread out across all 10 swings, which massively shrinks its impact on your final calculated mean value. Game changer, right? And the beauty of this is that it works perfectly for distance, too. It brilliantly rescues your length measurements for tiny objects. If an exam tells you to measure the thickness of one single page in a book, doing it directly is a terrible idea. The top band, high-scoring method is to measure a stack of 20 pages and then divide that total thickness by 20. It's the exact same logic. Okay, so the multiple strategy works flawlessly for repeating things like pendulums or stackable things like pages. But what if the object is in freefall and its speed is changing rapidly? In just a moment, I'll show you the exact examiner clue that changes your ticker tape answer completely. But first, you need the framework that makes that clue super obvious when you're dealing with fast-changing variables. When values are changing at breakneck speeds, you have to adapt. Our source outlines a few specific lifesavers. First, team up. Have a partner watch the timer and shout out exactly when to take a reading. Or, even better, hit the lap timer facility on your stopwatch. This actually freezes the display for a few seconds so you can write down a precise measurement while the internal clock just keeps on ticking in the background. But here is the ultimate scientific reasoning for our framework. For incredibly short time intervals in freefall, your basic stopwatch belongs in the bin. You absolutely must use an automatic device. A ticker tape timer or a data logger linked to a computer, triggered by electronic signals like a photo gate, is literally the only way to accurately measure rapid motion under 1 second without your own slow reflexes ruining the data. Let's switch gears to length precision and see how this levels up your overall practical skills. You've got to know your ruler's limits. Our source confirms that on some rulers, you can actually estimate a measurement to the nearest half division on the scale. So for a standard millimeter ruler, your ultimate maximum precision is to the nearest 0.5 millimeters. Keep that number in your back pocket. And hey, precision isn't just about rulers. When you're using measuring cylinders, you have to know exactly where to look, or you're throwing away easy accuracy marks. The surface of a liquid naturally curves, which forms a meniscus. For water, it curves downwards, so you read it right at the bottom of the dip. But for mercury, the meniscus curves upwards. That means you absolutely have to read it from the very top of the curve. The examiner also really wants to see that you know how to physically position yourself in the lab. You need to explicitly write down that you ensure the measuring cylinder is perfectly vertical, and most importantly, that your eye is exactly level with the meniscus. Using this specific phrasing proves you know exactly how to prevent parallax errors, which locks in those method marks. All right,
Challenge time! Let's put everything we've just covered to the test with an interactive Spot the Error challenge based straight on our source material about terminal velocity. Keep human reaction time and the apparatus for rapid motion fresh in your mind.
Take a hard look at this flawed student answer. I used a stopwatch to time the object falling 10 centimeters to calculate terminal velocity. Now, on the surface, this kind of sounds like a solid experiment, right? They've got an instrument, a set distance, and a clear goal. But this steps squarely into the examiner's trap for measuring rapid motion. Can you spot the fatal error before I reveal it? Ouch. This answer earns a brutal 0 marks. Why? Because an object in freefall drops 10 centimeters in an absolute fraction of a second. As we just talked about, your reaction time is about 0.5 seconds. That lag is just way too massive for a tiny 10-centimeter drop. Any data you collected wouldn't just be slightly off, it would be entirely fictional. Now check out how the top band answer totally fixes this. Instead of a basic stopwatch, the top-tier student writes, used a ticker tape timer or a data logger to measure the rapid change in distance over time intervals of less than 1 second. See the difference? They correctly identify the automatic apparatus needed for the exact physical reality of this specific experiment. If we run this through our 4-step framework, this top band answer totally aces it. They use the correct terminology, they pick the appropriate apparatus, their scientific reasoning flawlessly links the rapid motion to the specific need for a ticker tape timer, which completely bypasses the human reaction time flaw. This is exactly the kind of critical thinking Cambridge examiners are aggressively scanning for. So we've successfully rescued the practical method. You know exactly how to dodge the half-second reaction trap and those sneaky parallax errors. But honestly, your understanding isn't totally complete until you know how to analyze the actual, messy graph anomalies that spit out of these ticker tape timers. You might have mastered the apparatus, but the final examiner's checkmate is hiding right there in the data itself. That full rescue kit continues in the next part of this explainer series, and you really can't afford to skip it if you want that top grade. In fact, to make sure you don't miss out on exactly how to process this highly complex data, the creators of our source material recommends you subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Seriously, watching the next explainer is your mandatory next step. I'm going to leave you with one final brain-bending thought to chew on. When an object finally hits terminal velocity, how exactly do you calculate accurate gradients when your ticker tape dots start blurring together into one giant mess on your graph? Think about how you'd handle that crazy data anomaly, and I will see you in the next explainer to uncover the final checkmate. Keep studying smart.